Hello everyone. In this video I'm going to look at sketching the graph of a polar equation. In this case we have sketched the graph of r equals 3. So on a polar grid, normally when we graph a point we look at r and we look at theta. That tells us what angle to go around the pole, and then r being the distance we go out from the pole to mark our spot. Now in this case, we're just told that we have sketched when r is 3. R works a lot like a radius. So, if I have my polar sketch, what it's saying is, instead of giving me a specific angle to go out to, for example pi over 4, 2 pi over 3, etc., it's saying for any angle, I want to point at a distance of 3. So if this, for example, is 3 out. Let's say that's 3 and then that's pi over 4. That's included. Let's say 3 and pi over 3. That's included. And I keep going around a distance of 3 for the major angles we know and lesser known angles, and eventually if we keep going, so what it's saying is for any angle around that pole, go out a distance of 3. For the infinite number of angles we can have, this creates a circle of radius 3, and that will be our graph, a circle of radius 3. In some place I need to indicate that I've gone out a distance of 3. Another way of verifying this is changing this to rectangular coordinates. Trying to find a useful substitution, I can say, well, I know that r squared can be substituted as x squared plus y squared. That's one of my polar substitutions. I can square each side here, and that gives me r squared equals 9. R squared again is this, so x squared plus y squared equals 9 in rectangular coordinates. If you recall, this is our equation for a circle. A circle at center 0, 0 with a radius of 3, hence the square root of 9. This just confirms that our graph would be a circle with radius 3. And in general, we can say anything where we're asked to sketch r equals 3, r equals some value, positive, is going to be a circle with that radius.